Okay, so in this video here, we're going to be talking about exponential growth and decay and how to determine if your exponential will have growth or decay. So before we can do any of these problems here, we have to know the template for an exponential, and that is going to be y is equal to a and then b to the x power. So a will always represent your y-intercept value. So a will always be your y-intercept. Again, that's where it's crossing the y-axis. And then b is going to be your base. All right, so b will be your base. And the base is going to tell us if we have exponential growth or decay. So if b, your base, is greater than 1, that means you're going to have growth, right? That means we will have growth here. And if b is in between 0 and 1, so if you have b in between 0 and 1, you will have decay. Okay? So it's pretty straightforward, but the problems can be a bit tricky because sometimes you have to rearrange them. So if you look at our first example here, there's nothing we have to do here. I can clearly see that my y-intercept is going to be 5, right? That's right here. Here's my a. And then my base is 2 right here. And so I can clearly see that I'm going to have exponential growth because b is greater than 1. So on this exponential here, we are going to have growth. I'll go ahead and put that. We have growth here, right? Exponential growth. All right, let's go ahead and try another example. So here's our next example, and this one will be a bit more tricky. When you first look at it, you may be saying, oh, well, you have exponential growth there because my base right here is greater than 1. But we talked about how you may have to rearrange these. So remember your template, y equals a times b to the x power. And notice how I have a negative here on my exponent. I want to get rid of that. I want to simplify it down. I don't want to leave that negative. So what I'm going to do is rewrite it. I have y equal to 5. And then I'm going to break this apart. It's negative 1 times x. That's what's actually going on. And so what I can do from here, this 5 to the negative 1, I can use negative exponent properties and rewrite that. So remember, if you have x to the negative n, using negative exponent properties, you can rewrite that as 1 over x to the n. And you can go in reverse. If you have 1 over x to the negative n, you can rewrite that as x to the n. Okay? So we're going to be using this one right here. So I can rewrite this as a fraction. Instead of being 5 to the negative 1, it's going to be 1 over 5. So now I'm going to rewrite it as y equal to 1 over 5 all to the x power. And now you can see that your base is actually going to be less than 1. It's in between 0 and 1. So on this one here, we actually have decay. Okay? This will be decay. And if you really wanted to, you could then pick out your y-intercept value. I know that I can go ahead and factor out a 1 here. So if you want to, you could write in a 1 right here. And you can see that, okay, my y-intercept value there is going to be 1, right? That's where it's crossing the y-axis. That is my a value, right? All right, let's go ahead and try another example. So here's our next example. And on this one here, we're going to do the same thing. We're going to go ahead and break apart this exponent right here. So for example, we have y equal to 27 and then 1/3, okay, and then times x. That's what's actually going on. And then right here, we can go ahead and simplify this down. That's really a cubed root. So for example, if you have a square root, like if you have the square root of x, that's really going to be x to the half power. Or if you have a cubed root of x, that will be x to the 1/3. Or if you have a fourth root of x, that will be x to the 1/4, and so on. So what's actually going on here, when you have 27 to the 1/3 power, you're actually taking a cubed root here. And the cubed root of 27 is going to be 3. So I'm going to go ahead and rewrite it as y equal to 3 to the x power. And there it is. Now I can clearly see that my base here is greater than 1. So I'm going to have growth here. This will be exponential growth. And again, if they were asking for the y-intercept, go ahead and factor out a 1 now. And you can see that, well, I have a y-intercept value of 1. It's crossing the y-axis at 1 there, right? Okay, let's go ahead and try 2 more examples. So here's my next example. This one's a bit more tricky, and that's because you have to go back to properties of exponents. Think about what's going on here and how I can break this apart. I can clearly see that I'm adding here. I'm adding these two terms. I have a negative x and then plus 2. So think about what you can do here using properties of exponents. If you have the same base, so for example, if I have a base of a times a base of a, and let's say on this a right here, I have x, and on this a right here, I have n. So if I have the same base and I'm multiplying, I can add the exponent. So for example, I could rewrite this as a and then x plus n, okay? So think about what we can do here. We can go in reverse. I can essentially break this apart by saying y equal to 5 to the negative x times 5 to the positive 2. That is the same thing. And I know that 5 squared is going to give me 25. So now I have y equal to 25 times 5 to the negative x. Now remember, we don't want to leave that negative here, and we talked about what's going to happen here. This is really like a negative 1. So 5 to the negative 1 will be 1/5, right, using negative exponent properties. So rewriting it one more time, you're going to have y equal to 25 and then times 1/5 all to the x power. So here's my a right here. That's my a. Here's my b. Okay, so I can clearly see that my base is less than 1. I'm going to have exponential decay here. So I'm going to go ahead and write decay. And that one's done. And again, your y-intercept value is 25 here. All right, let's go ahead and try one more example. So here's our next example. And again, very similar to the other problem. What we're going to do is break apart this part right here. So we're going to go ahead and rewrite it. We have y equal to 4. Can't do anything there. But again, right here, I can go ahead and break this apart by doing 2 squared times, and then I'll have 2 to the negative x. And I know that 2 squared will give me 4. So this part right here will give me 4. And 4 times 4 will give me 16. So now I have y equal to 16 times 2 to the negative x. And again, we're going to do the same thing here. We know that this negative is really like a negative 1. So it's 2 to the negative 1, which will end up being 1/2, okay, when I use negative exponent properties. So now I have y equal to 16, and then I'll have 1/2, and then all to the x power. So again, here is your a, your y-intercept. Here is your b, your base. My base is in between 0 and 1, meaning I am going to have decay here. Okay, so decay. And again, your y-intercept value will be 16 here, okay? So that is it. That is how you can determine if you have exponential growth or decay. It's really not that bad. Just remember, if your base is greater than 1, that means you're going to have growth. If your base is in between 0 and 1, that means you are going to have decay. And always remember, you may have to break these down. You may have to rearrange them before you can determine what your base actually is. So I hope that you found the video helpful. I hope that you gained something from it. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that'd be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future, and I'll see you in the next one.